Okay, here we go. We have 8.2 and 8.3 in the same video. So 8.2 is data gathering. Go ahead and copy down this real quick. So let's talk about what a population and a sample is. When people gather data, they can't always gather data from the whole population. For example, if you were to try and gather data about the city of Port St. Lucie or Vero Beach or something, it'd be almost impossible to get everybody's information because there's just a lot of people and there's not enough time. You have to think realistically about this. So in order to get information about a population, we take what's called a sample, and a sample is a part of the population. And so when you find out information from a sample, that's called a survey. Now, if you are able to get information from a whole population, that's what's called a census. And so what a census or a survey does is it just gathers information from the group of people that you want to get information from. So example 1, decide whether the sampling method could result in a biased sample. Explain your reasoning. So before we go on to that, we have to talk about what is bias. Bias means that when you're conducting a survey or a census, you're not choosing people that reflect the answer that you want to get. You don't want to choose people. If you want a true, what am I trying to think? The words are, if you want to get a true picture of what's going on, you don't want to just ask people that you know are going to give you the answer that you want. So bias is something that you want to avoid when you're conducting a survey or census. So it's pretty important in statistics, and this is what we're going to talk about here. So decide whether the sampling method could result in a biased sample. Explain your reasoning. So part A says a survey is conducted by calling 100 people randomly, chosen from a phone book, and asking how long each person has lived at their current residence. So this one I would say is biased, and there's a couple reasons why. If you think about it, some people in the phone book are they're not necessarily representative of the entire population of the city. Not everybody that's in the city is in the phone book. So there's already, the people that are in there, they don't represent maybe all the children that are in the city. That's one way you can think about it. And the people that are in the phone book may not even live in their residence anymore. So that's another thing you have to think of. So I would say that this is biased for that reason. Part B, the survey of students at the high school is conducted by contacting every 10th student from the complete roster and asking whether he or she plans to go to college. So if you think about it, every 10th student, that's not cherry picking anybody. That's just randomly selecting. It's totally random. There's no bias there because it's just random. So anytime it's completely random, you can say that it's not biased. And by the way, another thing, besides that, the fact that it's every 10th student, it's also from the complete roster, meaning that everybody's eligible to be contacted as part of the every 10th student. So nobody's left out. Whereas the phone book example, certain people are left out because not everyone's in the phone book. So you have to kind of think about these things a little bit. But once you think about them, they're pretty easy to say, okay, I can see why it's biased or not biased. Okay, example 2. The owner of a health club wants to determine the percent of adults in his area who exercise for at least 20 minutes 3 times a week. He asks the first 25 adults he sees at the mall on a weekday around 10 a.m. Are the results of the survey likely to be representative of the population? And explain. So let's think about this. So there's this guy, he's at the mall at 10 o'clock on a weekday. If you think about it, who's not at the mall at 10 o'clock in the morning on a weekday? Well, let's assume the school's in, okay? Because that's a possibility. If school's in, then teachers and students are not in the mall, most likely, unless they're skipping. Many jobs are 9 to 5 on the weekdays, meaning that you're going to have a large amount of the population that is most likely not going to be eligible to be part of this survey. So would this survey that he's conducting represent the population very well? I would say no, because many people are not, we could say it like this, many people aren't present for the survey. Another thing you can think of is he's only selected 25 people, and he wants to determine the percent of adults in his area. 25 is not a lot of people to survey to get an idea of an entire population of, let's say, a city. 25 is nowhere near enough for, let's say, a city's population. So that's another thing we can say is the sample. Let's say it like this: the sample is not large enough. You may also, and I'm going to stop here with example 2, but you may also have another reason why, and in fact, if you do, I'd love to hear it. But these are just 2 things I thought of that makes this not a really good representation of the population. So if you have anything else, you should let me know. Example 3, in a survey of 50 students at a high school, 32 students said they plan to attend the homecoming dance. The school has 720 students. Which of these numbers is a statistic and which is a parameter? If you notice that I underlined these in blue and then orange, because in blue, statistic is just a number that describes something in a sample. So if you notice, I kept everything blue that goes for sample. And then a parameter is just a number that describes something of a population. So a statistic and a parameter are the same thing. They're numbers that describe things. It's just that statistic is for sample and parameter is for population. One way we can think about it is P, parameter and population, S, statistic and sample. It's probably a good way to remember it. So which of these numbers is a statistic? Well, you would say that the 32 students is a statistic. And the parameter is the number of students who plan to attend. Who plan to attend. Again, I want you to think about this. This is a subset, or this is a part of this. So a statistic should be something that represents the population, or the parameter. And now let's actually do a little math here. Predict the number of students that plan to attend the homecoming dance. What we're going to do here is we're going to go ahead and set up a proportion. You've done proportions before, even beyond my class. If we think about it, let's start with the sample. We're going to start with the sample, and we're going to set that equal to the population. It's pretty easy. For the sample, we have 32 that plan to attend and 50 in the survey total. So we're going to say 32 over 50. And we're going to set that equal to another fraction. Now, if you think about it, 32 was how many plan to attend, and 50 was the total number in the sample. In the other fraction, what I want to put the total number of students that are in the population, which we know is in the school is 720. And we're trying to predict the number of students in the whole school that plan to attend the dance. We don't know what that number is, so we're going to call that x. Now, when you have 2 fractions equal to each other, you can cross multiply. So we're going to do 32 times 720. Oh boy, I don't have my calculator on me. Just give me a second. I'm going to get my calculator out. Okay. Well, you get 50x. Oops. You get 50x equals... I actually can't find my calculator. So we're going to do some old school multiplication. 0, 6, 21, 0, 4, 1, 3, 2. Okay? And then if you solve for x, you divide by 50. And you get about 460.8. So we'll say about 460 students. We'll say about 460 students plan to attend. Okay? So that's the notes about data gathering. It's pretty simple. Just with the bias, you got to think about it. And this is pretty straightforward. So let's go to 8.3. Surveys, experiments, and observational studies. Go ahead and copy down these 2 words, experiment and observational study. And also copy this down because I just forgot to type that in there. So we have experiment. Experiment imposes treatment and records responses to the treatment. So an experiment is where the experimenter actually influences what's going on. Maybe they give a pill or some similar kind of medicine, or maybe they provide something. Like a classic example is, you put a rat in a maze, and the experimenter puts the cheese at the end, and so he has influenced the environment, and the rat, he wants to see how long it takes for the rat to get through the maze and get to the cheese. So that's an experiment. That's different from an observational study, where the experimenter, or I should say, the person who's doing the study, he only observes, and they don't influence or interfere. They just want to see what happens as time passes on. So let's do example 1. Explain whether each situation is an experiment or an observational study. A researcher asks students the average number of hours they sleep per night and examines whether the amount of sleep affects students' grades. So if you think about this, well, is the researcher, are they influencing what's going on here? No, they're just observing what's going on. So this is an observational study because they have no influence whatsoever on how the students sleep or on their grades. They have no influence whatsoever. Part B, a park employee wants to know if latex paint is more durable than non-latex paint. She paints 50 benches with latex paint and 50 with non-latex paint. Well, in this case, the treatment, and actually I want you to write this down, but the treatment is latex paint. Actually, it's latex and non-latex paint, we should say, because she is applying both. Well, because they're applying a treatment and seeing the results and the responses, this is definitely an experiment because the employee is influencing what's going on. Example 2, the study described in the report is a randomized comparative experiment. Describe the treatment group, and the control group. And here's the study. This is pretty shortened, but at a middle school, 50 randomly chosen students were given milk every day for a year, and 50 other students were given other beverages. So let's go ahead and describe what the treatment is. The treatment here is drinking milk. So that's what's being given. That's what the researcher is influencing into the environment. Now, they tell us to find the treatment group and the control group. So which group would you think is the treatment group? Well, that would be those that drank the milk every day. 50 students who drank milk. And then you have what's called the control group. And anytime you hear the word control group, that's the group that they're needed for comparison, but they don't actually get any of the treatment. They're there to see what the effects are like between the people that are actually getting the treatment and people that don't receive that treatment, so that the experimenter can compare results. So in the control group in this case is the 50 students that were given other beverages. So the other beverage group, we'll call it. Keep it short and simple. Okay. Explain whether the research topic is best addressed through an experiment or an observational study. Then explain how you would set up the experiment or the observational study. And the study is, does listening to an MP3 player with earphones for more than 1 hour per day affect a person's hearing? One thing we have to talk about before we talk about whether you do an experiment or an observational study is this study ethical? So we're going to talk about ethics for a moment. We're really diving out of the world of math here by talking about ethics, but let's talk about it for a second. When you conduct an experiment, you always have to keep in mind that you're dealing with real human beings, and you can't harm them. It's not okay. And, they can sign waivers, blah blah blah. But the point is, when you're thinking about questions like this, make sure that you're thinking of, is it okay to subject a human being to what I want to test? And sometimes you might not even think it's that big a deal, and to some people it might be that way. But you got to remember that it's just the way the world works. Is sometimes you have to really think about things with ethics, and this may, you might not agree with this, but if you subject somebody to listening to something for more than an hour, that could potentially, maybe harm their hearing. Their hearing may be impaired with this study. So this may not be the most ethical study to impose upon somebody. So we have to keep that in mind. So it's not ethical to assign a treatment group. It's not ethical to do anything like example 2 here, where we were given, milk to some kids and other beverages to other kids. So this is better done as an observational study. That's our answer here. Based on the ethics. The ethics determine that this should be an observational study. Because we don't want to harm someone's hearing just because we want to see the results. It's a huge issue, and it's just something you have to accept with this chapter. Then explain how you would set up the experiment or the observational study. Again, we chose observational study. You might have a slightly different response. This is more open-ended. Maybe you could choose, 5 people that are willing to do it, and already do it. So maybe 5 people already do it. 5 people that already do it. Already listen for more than an hour. And then maybe choose 5 people that don't. You can compare the 2 groups and see what happens. So, there you go. I'm going to have to end the video right now. Sorry there's no shoutouts or jokes. Sorry.